It's 1815.
Thank you. Okay, so starting where we left off, we figured out that the result of step 1 was that our integral is equal to negative square root of 3 times the integral of cotangent squared theta d theta. And this is the triangle that we used. Okay, so now for step 2, we need to evaluate our trig integral. So in order to evaluate it, let's see, we've got negative root 3 times the integral of cotangent squared theta d theta. Now let's think about what we would do if we needed to integrate the integral of tangent squared theta d theta. What would we do? Well, from the videos, we remember that in order to integrate tangent squared theta d theta, because it's an even power of tangent and the power of secant is 0, we would use our trig Pythagorean identity to say that tan squared theta is equal to secant squared theta minus 1. So we would rewrite this as the integral of secant squared theta minus 1 d theta. And then we would split up the integral, so we'd have the integral of secant squared theta d theta minus the integral of d theta. And then we would say, what is the integral of d theta? Oh, that's just theta. And what's the integral of secant squared? Oh, that's tan theta. Right, and then we'd say plus c, plus a constant. So we're going to use pretty much the same idea for cotangent squared, right? So just like tangent squared has an identity, or is part of a Pythagorean identity, we just need to figure out what is the relationship between cotangent squared and cosecant squared. And we'll be able to pretty much use the same kind of reasoning, just with cotangent and cosecant instead of tangent and secant. So looking at this, let's remember this, we're just kind of jotting to ourselves. Sine squared theta plus cosine squared theta equals 1. Now I need a relationship involving cotangent squared theta. So I need to divide this by sine squared theta. I can't just divide cosine squared theta by sine squared theta. I need to divide every single part of this equation by sine squared theta, right? The left-hand side and the right-hand side. So this is going to leave me with 1 plus cotangent squared theta equals cosecant squared theta. What is the relationship? Cotangent squared theta is cosecant squared theta minus 1. So let's rewrite that over here. This is equal to negative square root of 3 times the integral cosecant squared theta minus 1 d theta. Now we can rewrite this as negative root 3 times the integral of cosecant squared theta d theta plus root 3 times the integral of d theta. Now, what is the integral of cosecant squared theta d theta? Well, now whose derivative is cosecant squared? Negative cotangent squared. So this is going to end up being root 3 cotangent, sorry, not negative cotangent squared, just cotangent. Cotangent of theta, right? Because the derivative of cotangent is negative cosecant squared. Okay? And then plus this last summand is going to be root 3 theta. We can put a plus a constant. So we're done with step 2. So this is our result for step 2, is we've evaluated this trig integral. Okay, so let's clean things up a little bit and erase over here. Now we're ready for step 3. And step 3 is where we use the triangle to back substitute. So we've got our answer here in terms of theta, right? So what we've done is we've said essentially the integral of x squared, what is this, x squared minus 3, the square root of that, divided by x dx equals negative root 3 times the integral of cotangent squared theta d theta, and that's equal to root 3 cotangent theta plus root 3 theta plus a constant. Now this doesn't make any sense unless I know the relationship between x and theta. So this again is where we have to use that triangle. That's a horrible triangle, so we're going to try again. Much better. And our triangle has theta down here, and the length of this leg is the square root of x squared minus 3. The length of the other leg is the square root of 3. And the length of the hypotenuse is x. Now, from here, I should be able to figure out what is theta, right? So I've got stuff in terms of theta and d theta, and I need to convert it into, or not d theta. I've got an answer in terms of theta, and I need to convert it into an answer in terms of x. And so the parts that I have are, I've got cotangent of theta, or times root 3, and I have root 3 theta. So the question is, what is cotangent of theta in terms of x? I look back at my triangle, and I say, what's cotangent of theta? Cotangent of theta, remember, is going to be cosine of theta over sine of theta. It's also, so yeah, we can do it that way. Well, maybe it's better for us to say cotangent theta is 1 over tangent theta, 1 over tangent of theta. And tangent of theta is is opposite over adjacent. So this should be adjacent over opposite. So looking at our triangle, we should get square root of x squared minus 3 over square root of 3. All right. So if we take this and multiply it by square root of 3, we'll have square root of 3 times the square root of x squared minus 3 over square root of 3. Those coefficients are going to cancel out, and we just get the square root of x squared minus 3. What about the theta? This one is probably the trickiest. In order to convert theta into an expression involving x, again, we're going to use the same triangle. What's the relationship between theta and x? Well, the simplest relationship would be to notice that sine of theta is root 3 over x. Right, so since sine of theta is root 3 over x, what is theta? Theta is going to equal sine inverse of root 3 over x, right? Which is the same thing as saying arc sine of root 3 over x. So we'll have here root 3 times arc sine of root 3 over x. All right. And now since this problem is, I guess we could put here that this is equal to square root of x squared minus 3 plus root 3 arc sine root 3 over x plus a constant. All right. Now, because we have an indefinite integral, we've got this, step 4, which is to kind of do the evaluation at the endpoints. So the integral from root 3 to 2 of x squared minus 3 square root over x dx is equal to square root of x squared minus 3 plus root 3 arc sine root 3 over x, and all of this evaluated at x equals root 3 to x equals 2. Okie dokie. So if we plug in x equals 2, we're going to get the square root of, so that should be the square root of 1, which is just going to be 1, plus root 3 arc sine square root of 3 over 2, okay, minus, now we plug in root 3. So root 3 squared is going to be the square root of root 3 squared minus 3, that's just going to be 0, plus root 3 arc sine root 3 divided by root 3, that's just going to be arc sine of 1. So now we need to know what is arc sine of root 3 over 2. That's essentially saying sine of what is equal to root 3 over 2. Sine of pi over 3 is root 3 over 2. So that'll be pi over 3. And then we've got this root 3. Okay. And then minus, and this will be 0, plus, what is arc sine of 1? Sine of what is equal to 1? Sine of pi over 2. So it'll be root 3 times pi over 2. And we can simplify until our heart is content. So we would have 1 plus root 3 pi over 3 minus root 3 pi over 2. I don't know why that happens. All right,